In this video, we'll be wiring up the Trinary switch that comes with your AC hose lines for your 88 to 98 Chevy truck. Hey, I'm over here at Kwik Performance. We just got done installing our sand and mini compressor on this 98 Tahoe, and we've got it all plumbed up with our lines. And this one we did an electric fan, and so I'm going to show you how to wire up the Trinary safety switch to help protect this compressor and run these electric fans, and how it also ties in with the thermostat wiring for the electric fans as well. Wiring varies quite a bit from vehicle to vehicle, but we'll kind of give you the endpoints where we hook it up and go through how to get yours up and running. So we have our sand and mini compressor installed. We've got our Kwik Performance AC hose lines to connect from our accumulator and dryer out to our condenser here. And one of the things that this kit comes with is a hardline fitting to go through your core support and a Trinary switch and a port to connect the two so that you can wire up your Trinary switch and use it to protect your AC system. And in our case, if you're running electric fans, there's also a connection point to a relay setup to tell our electric fans to turn on when the AC compressor gets to its designated pressure. So the main thing you're going to need to find is a ground. In this case, we have a vehicle ground here that's already tied in, and our temperature sensor requires a ground as well. We are going to pull our AC signal from the wiring harness that comes off the engine. It is fed through our low pressure cycling switch here at the dryer. We highly recommend you keep that in line with your wiring. And then this is the wire that goes to a sand and compressor. Sand and compressor runs off of a single wire, and it is grounded to the engine and to ultimately to the frame of the vehicle. And then we have our electric fan wiring, which is down here. And we'll get all these together and tidied up. Here I'm connecting the wire that tells the relay to turn the fans on low to the low temperature wire terminal off of our thermostat so that I can combine the two together to run off of the fan control wire from our Trinary switch. Then, of course, we're going to do a marine sealed heat shrink butt splice everywhere we have to make one. Well, there are 4 wires that connect to the Trinary switch. And as unlikely as it is in a typical situation that this would fail or you'd need to replace it, I'm going to use a weatherproof connector, a 4-wire connector, to these 4 wires so that it can be easily disconnected. And I'm going to combine my ground signal for my thermostat and for my fan relays. And I'm going to combine my low temperature fan control wire and the low speed fan signal wire to 1 wire to connect to my fan control wire here. So I will have a total of 2 wires AC signal in and out, and a ground and a ground signal wire that goes to the electric fans that are all going to make up into the other side of this harness to connect to my Trinary switch so it can just be unplugged if I ever need to service the AC system. All right, we've decided that, again, because this truck may get used as a test mule from time to time, that we want to make the Trinary switch easily removable. So I'm installing a weather pack connector here to keep the fittings and the connections clean and secure while making it completely removable should the need arise. All right, last connection going in. This is the AC signal coming from the Trinary switch that will go out to the compressor. Again, the Trinary switch is not really designed to control your compressor as much as to serve as a safety measure to prevent an over or under pressure condition in your AC system. Now I've got my ground, my AC signal coming from the low pressure cycling switch, my signal out to the AC compressor, and my fan signal coming from the trinary switch to turn on the electric fans. I'll go ahead and wire these up to the other side of the Weatherpack connector. Now, most electric fan relays are set up with a ground switch setup, meaning that the relay is supplied with a constant positive 12 volts. And whatever controls your electric fans switches the ground. So our trinary switch passes the ground signal from the vehicle chassis to the fan switch in the condition where the compressor reaches a sufficient pressure that it needs to cool the condenser. The positive signal passes through from the AC signal from the vehicle to the AC compressor, and that cuts out at a dangerous low pressure or dangerous high pressure. Otherwise, it remains connected while the AC is turned on. All right, we've got all our connections made up here on our 98 Tahoe for our AC wiring with our trinary switch and electric fans. Just take you through it one more time. We're going from our vehicle's wiring harness, passes through from the cab. So when you turn on the AC, it comes through, signal runs through your low pressure cycling switch here at the accumulator dryer, and then runs back through the harness and comes around and comes down past our compressor. And the next stop is this wire that goes into our trinary switch and then comes back out of the trinary switch, just runs right back up and feeds our compressor right here. And then our trinary switch requires a ground to operate. So we have our ground that just runs down here to our vehicle's body, our frame rather. And then we have our switched ground that comes out of our trinary switch and runs our electric fans and runs parallel to the low temperature fan switch from our temperature sensor from our coolant, which also turns the fans on low. So that's it. We have our AC all wired up and fully protected by our trinary switch, and it's also set up to control our electric fans. And we've just found in this case that the fans on low is a more than adequate cooling for our AC system. LS 6 liter runs pretty cool anyway, and so the only time the fans ever run on high is in a high temperature or heavy load situation. So that's how we've wired this one up, and yours may vary, but generally speaking, that's the sequence of wiring for your AC trinary switch. Just as a fun little bonus, if you happen to order one of our metric AC hose kits, the metric dryer fitting comes with this black cap on it, and David, our tech guy, was kind enough to point out that it fits nicely over the top of the trinary switch and the wires, and just kind of helps hide that and secure that right there. So we'll get these wires all zip tied up and tidied up. So our kits come with the trinary switch and these instructions that talk you through how to wire it up. We use the trinary switch wiring that controls our electric fans, but if you're just using the switch as a binary switch to protect your AC system with a mechanical fan, then the other instructions are on the back side. Depending on our supplier, sometimes our wire color codes on the switches differ. We will make sure that you have the correct instructions with a correct color code in your kit. So just follow along, make sure your connection points are good and solid, and you'll have cool air in no time.
Oh, goodness.
All right, so in order to run this system, we're obviously going to have to get power to the compressor. And what we'd like to do is for you to be able to push the button on the inside and it worked just like the OEMs did, correct?
Absolutely.
So where's the power from the switch coming out to here?
Well, what we find is that typically runs right up to the accumulator. And at the accumulator, you will find the AC signal wire. Now, going out of that switch is the second wire.
Okay.
And that wire right there needs to go to the trinary switch. That is what is going to run into the trinary switch.
Now, we don't want to run directly from there to the compressor because we need to go through the trinary switch so they have high and low pressure protection, correct?
Exactly.
Okay.
Exactly.
Now, is there any complications to making that happen, or is it pretty straightforward?
Pretty straightforward, because we provide a wiring diagram in our instructions. And like I say, it's straightforward. It says AC signal. It tells you what color the wire is. You tie into that. Then it tells you which wire to tie onto to go to your compressor. One of the things you're going to find on your compressor, you only have one wire now versus what GM did with the R4. They had multiple wires on some of the R4s.
Okay.
You're going to need to ground that system. And so in order to ground it, you're going to have to tie into the trinary switch. And you can either ground it on your frame, your body, but you need a good ground.
Okay. Now, there's going to be an extra wire if a guy wants to run an electrical fan. What's he need to do if he's not running an electrical fan?
So if he's not running an electrical fan, just don't use that wire.
Okay.
Cap it off.
Just cap it off, put some tape on it, whatever.
Save it for the future, because as you continue with your vehicle, you may wind up doing an LS swap or something later down the road. You may decide you want electric fans.
Yeah.
So in saying that, cap that off. But if you do have electric fans, on our instructions, you'll find that we actually have a wiring diagram for the electric fans. You'll see that wire goes to a relay. It doesn't go directly to the electric fan. So make sure you use that relay, which that's included in the kit.
Yeah. Outstanding. Is there anything else the people at home need to know about wiring this thing up?
All in all, straightforward, just what we just explained. What you'll find on the 94 Chevy GMC trucks is you can actually pull out of your harness where it goes in the back of the R4 compressor. Got to do a little checking on your wires with the multimeter to find out where your power is coming from, because they stuck 3 different switches back there.
Okay.
So it made it nice for this build because we just used the factory harness, tied it all into our trinary switch. It's clean, it looks good.